Hello, hello everyone. Yeah, through the Vox speaker, I'd say that speaking about monoliths, is it a modern topic to speak about monoliths? Uh, Maybe the monolith itself not, but a modularized monolith is a different thing, right? So we'll be talking about a modularized monolith. So not this ugly thing, but this nice modularized and well-crafted monoliths. I'm from Poland. I'm working in Warsaw in Circle K, where the important thing to mention is that all that I'm presenting right now was crafted in Circle K in our IT division in Warsaw. Also, I had a chance to prepare this presentation for you and present it to you. So that's a very good point for me. And let's start with the slides. Um, Some of you might be familiar with this graph where you can separate, split systems, distinguish systems based on whether they are distributed or modularized or not. Uh, so distributed and modularized, we have those microservices. And so, well, not distributed and not modularized, we might end up with this ugly monoliths, which we call sometimes big ball of mud. Well, because everything is tangled inside together, and we have troubles in finding boundaries. So this is a place where we want to escape from, right? We want to escape from big ball of mud, but where to escape? Many years ago, we were discussing that microservices is the way to go. So a lot of people were trying to distribute their big ball of mud, which ended up in a distributed monolith, which is not a good thing because, well, you have all the drawbacks of monoliths and all the drawbacks of microservices, none of the benefits. So probably the best way to go is to first decide on how you're going to modularize your monolith, and then each of the module can be deployed as a separate deployment unit. If you decide that it's also that it's important, that it's a valid step, right? Because you might end up with a modularized monolith, and it might solve all of your problems when it comes to separating business logic and domain logic. Maybe distribution is not required. If it is, then the next step after modularizing monolith would be well, to split it into separate deployment units. So on the presentation, I'm going to be focusing on modularizing monolith. A very short agenda. I'll be talking about the decisions and the path and discussions that we've had in a team on how to approach the modularization, and then tactics. So how we actually implemented things. What tools did we use and what practices did we employ? A small disclaimer here, I'm not going to discuss on how module boundaries should be defined. I mean, it's a business specific and properly specific to your project. What are the modules? Where are the boundaries? I assume that you already have an idea or a modules already defined, right? You know how where modules are in a business context, and now we want to restrict and keep the boundaries on these modules. So the long story short, let's start with a project. Just a short intro what we did in Circle K. It's an identity management system for customers, which is a login screen for customers, including this customer profile management, and all those things related to user profile management, right? Customer can manage his profile there. So it exposes a UI. It allows user to log in and manage their profile. So it's a kind of standalone service. It has its responsibility and its role. However, the user data is being used by other services within the company. This is what is forming a microservice architecture, because also those services are being accessed by customers. So customer can go to the service, enroll for that service, log in into our system, and then come back to the service, right? So we are in a microservice architecture here, where the system that I'm going to be discussing is one of the microservices, with well-defined responsibility. So the perfect microservice, I would say, because it all started as a very simple service to authorize a user, authorize and manage user data. So it sounds like perfect little thing to manage and to build, right? So let's say that there was a set of classes represented by those boxes on a backend. On a backend, we've had a structure like layered architecture, so controller services and DAOs. We've had integration tests for that and no unit tests for that. That might be scary, and it was scary for me when I was joining the project. That there's no unit tests, all right? You have to have unit tests. That was my thinking back then. But once I observed how those integration tests are behaving, that they are fast, they are easy to build, easy to construct, and they are proving that the system is working, then, well, I thought that for this size of the project, maybe this setup is fine, right? So we lived with that. We added unit test later, I'll mention that, but we added it on a purpose, right? So not just because they have to be here. And the front end. I'm not going to discuss front end much here, but the important thing is to mention that while this slice of authentication and user data management also has its own UIs, right? So it has also some front end as well. And there to our small perfect microservice came this small feature. There was this year in European Union, maybe you remember, where all software developers were united in all countries and implementing GDPR, right? To collect customer data or to delete customer data from all systems in the company. So were we, and GDPR process was on us, on this system, right? So the whole GDPR handling in the company was on us. So we decided that it fits user data management. However, it doesn't that much fit authentication and user data management. So we've seen at that point that it's something separate, and we reflected this separate thing with a vertical line here. In Java, it's simply a separate package, right? A package called GDPR. That's the simplest implementation of Modularized Monolith. You might have a package. The structure of classes in this package was plain. We decided not to enforce the layered architecture here. So all the classes were organized here more into onion architecture. But well, the important message is here that we didn't want to enforce the internal architecture here on this module. We continued with the testing approach. So we've had an integration test and unit tests. However, the important part here is that we've noticed that integration tests are getting more and more complex to construct because the project is getting bigger. So we decided that the next step would be to add unit tests. Front-end structure, the same, right? So it also has its own UI. Not important to discuss here. And the next step was that, well, that was not the end. Still, we got one more responsibility added to the system. And it was terms and conditions management. So TC management. This is this, checkbox that you check that you have read and accept the privacy policy and terms and conditions once you join the service. This is what we've added. And again, we felt that we should follow this structure of splitting vertical slices. Right? So terms and conditions became yet another module, but well, now yet another package, but now it's going to be called a module. And I will show you what this small empty space here means for a module. So terms and conditions, it has also a set of classes, controllers, services, and DAOs, and front-end structure was also reflected. And the important part, let's fill in this blank now, right? It's a module API. So this is what we call a module. A module is a package that has a module API. And module API is a class or a set of classes or interfaces that are being the implementation is not important. The fact is important that it's a facade to the module internals. So once you have some behavior on a module, like terms and conditions, you can accept terms and conditions or revoke them or review them. Then those three behaviors, like accept, revoke, and review, can be defined as an API to this module. And module API has those three behaviors: the business written in a business language, and well, the module API is delegating calls to this internal structure. So it's encapsulating the module behavior. Module API is dedicated to be used by other modules, right? So other modules are calling only the API. They're not calling the module internals. This is the only exported, only public class in the module. Also controllers, so from the infrastructure layer, they are calling the module API. Since the module API class and behavior is so important, it was high time for the unit tests to appear. Right? And the unit tests, they are testing the module API. Right? So they are proving that the contract on module API is held and is valid and is working. They are not testing internal classes, so class by class. Like sometimes you might have a unit tests that are, testing single class and having a set of mocks. We are not mocking. We are testing real implementations, but encapsulated in internal structure. The benefit is that internal structure inside the module might change, but the module API stays the same. And the fact that it stays the same is confirmed by the unit tests, so that other modules and controllers might freely call the module API, and they have a guarantee that the module API is up to date. I have the whole separate presentation on a module unit tests, so you can refer to that on YouTube someday. Right now, let's go to the next slide, because we're in some stage in the project. We were back then that module API was created for user and of two modules. So we have had all those vertical slices defined as modules, and well, the new modules popped up. So we were designing new modules, enhancing existing ones, deciding on the boundaries, and so on. This is where we were in the project. But one more important thing to mention here. I've been discussing a code, an object-oriented code. So there's always this thing that we need to mention, because there is database, which is not a good fit for object-oriented code. And since we are in monolith, well, we were all working on the same database instance. So all modules were on the same database instance. They were using separate set of tables. However, the risk here is that between those tables, there will be some relationships, like foreign keys or cascade deletes or cascade, any other cascades. So there's a risk that once you are going to separate deployments of, for example, terms and conditions module, you need to make sure that on a database level, you don't have any relationships, because once you deploy it to a separate database instance, then you will lose it. So the one way is to handle it first. You need to have an integration test that is testing those database relationships. And once you separate the TC module, the integration test will fail, because there is this constraint. Other way is to implement constraints in Java code, not on a database level. Like, for example, if you delete user, you do not do drop cascade delete in a database, but user module should notify another modules on the fact that user was deleted. And GDPR and TC modules might process this opt-out. In my case, deleting a user is not simply removing a row from database. There's a much more complex process of opting out a user. So this is why we prefer to keep it in Java. It might be less performant, So this is the drawback. Yeah, the choice is yours on how you approach it. Let's go to the next slide and talk a bit about the future, because we ended up with this modularized monolith, and there was this idea to replace the identity module because it was internally crafted, and we might be using instead, off-the-shelf solution. So remaining modules might stay, but this module might be removed and replaced. Once you have it modularized, you clearly see the boundaries. You have the API, and you see what APIs are being called from this module, right? So thanks to that, you're able to clearly define a contract of this module. So once you deploy it to a separate deployment unit or you replace it, then you know what features it was serving and what should be replaced and how to approach the migration. Okay, so we're in a step that we know where we are going. We know what module definition is. The definition is mature. The modules are still growing, but module definitions are not changing. And the current setup is working. The team feels good with it, so we decided to strengthen the boundaries. So before that, we were enforcing those rules and keeping those boundaries manually during the development. And you know what happens? You might forget, you might miss something on a pull request as well, and the boundaries are broken. That's very simple to do with this complexity. Another thing that we wanted to do is to find gaps where we are not modularized, because we were not modular from the day one, so there might be some leftovers from the past. And also we might have done some mistakes during the new development. So this is what we wanted to detect also. What I mean by broken boundaries, the perfect case is that the module API is being called by the external modules are calling the module API to access the module functionality. However, the broken boundary means that some classes are breaking this requirement, right? We want to eliminate those two red arrows to have the full modularity and the clear architecture in the system. So we were hoping that there is a tool that will help us to detect it and to fix it. The requirements we've had was to automate the rule checking on new development and on pull request and on continuous integration. And the second goal was to allow to scan the system and find where we are not yet modularized so that we can modularize it. And maybe you already come up with some ideas, like Cradle modules, like Java 9, like maybe something different. I'll start this discussion here with Java 9, because the Java 9 was released back then and the Jigsaw was pretty loudly discussed. Maybe because it caused a delays in releasing Java 9. So yeah, Java 9 has a modularity concept embedded right into the JVM concept. So there is a chance, there is a possibility to define a module and limit the accessibility of the classes within this module. So we can export the single class that is being an API to this module. It helps, first of all, to organize the code, and second of all, it might help in reducing the size of the artifact so that it's smaller. Right? You don't include in the artifact the modules that are not needed. However, well, we were a bit afraid of it, to be honest, because there was not that big adoption in the enterprise project of Java 9 modules. There were books I can recommend O'Reilly. There were just a few conference sessions on that, so we were afraid whether this is a good way to go. Also, the Java 9 modules is limited. You can only define rules on module access. This is actually what we need, but can we have something more? And there came the ArchUnit. I won't be discussing the Gradle modules, maybe one more thing. I won't be discussing the Gradle modules because they work on a similar level, on a similar mechanism, Gradle or Maven modules. So I'll just jump into the ArchUnit, which is a library, as opposed to the Java 9, which is a language concept. So it's a library that you're adding ArchUnit to tests, to test dependencies, and you're creating a unit test. A unit test for your architecture. This is what it's called an ArchUnit, where you define when you define the conditions, you build a rule and you check whether this rule was satisfied or not. Also, you have here a pretty fluent DSL that's allowing you to build the assertions and construct the test. I'll show it to you details later. Important part is whether this is actively contributed system library. Yes, it is. It has 49 contributors and 2 or 3 first of them are very active and they are leaders here, right? So they keep the vision. Let's jump into examples. We've selected ArchUnit because of its flexibility. I will show you what you can do with ArchUnit. I'll start with the simplest scenario. It's not related to testing architecture, but it will show the API, how to use the API of ArchUnit. So here, let's say that we want to avoid a field injection. Right? We want to use constructor injection. We don't want to have auto-wired on a field, a private field. And ArchUnit can help us to write a rule and test on that. Actually, this is it. This is the whole thing that you need to write. The ArchUnit creators decided that you might have this shorthand syntax. Actually, you are annotating a field of type architecture rule, and no classes should use field injection is a constant delivered by ArchUnit. We'll take a look deeper what's hidden under this constant here, and I'll show it to you later. The important part is the violation itself. So you're having this error report that rule no classes should use field injection is violated because field injection is considered harmful. Use constructor injection or set injection instead, yeah. And you have a Stack Overflow link for detailed explanations. And guys, let me pause here for a moment. You have Stack Overflow link for detailed explanations. Not a design patterns book, not a Spring framework documentation, not dependency injection framework, not even Wikipedia. You have Stack Overflow link. So might I ask a good question or give a good answer on Stack Overflow, and you will be quoted in libraries. Okay, and you have 5 fields where this was annotated with auto-wired, with inject, or that the rule is violated, basically. Yeah, but this is not interesting from our point of view because we don't want to scan and just use the constants. Let's see what's implemented under the hood. So no classes should use field injection is defined as no field should be annotated with an injection annotation. So yet another constant under the previous constant. We'll of course dig deeper under the following layers. But important part here is that here you have a defined error message, violation message, right? So no classes should use field injection because it's harmful, and here you see this Stack Overflow link. Let's see what this constant is and how you define the rules actually. So you have an architecture condition on Java field, which is this constant. And well, internally they have a method. And finally, we can check what does it mean. So we have 5 architecture conditions here on Java fields, and each of them is checking a different annotation. Spring auto-wired, Spring value, juice inject, Jakarta inject. And the way to check it is use DSL from ArchUnit. Spring auto-wired or Spring value or juice inject, right? In the end, you are checking all those conditions. If any of them is broken, is violated, then the violation is being raised as an architecture condition that has failed. And that's it. The internals are important because once you're going to write a more complex rule, like I'm going to show you later, then then you need to know how it's implemented under the hood. You're not going to use the constants from ArchUnit. Similar thing you can do on coding rules, like I will show you here two ways of defining architecture unit test. For example, if you want to write a rule to avoid using the standard streams, like system out println, you have two ways to do it. First, you can define a field, like in the previous example, or you can define a unit test. And a unit test annotated with archtest, and it will check if no classes should access standard streams, and will check those classes. So that's it, but let's go into more interesting cases. Like we're not going to test to do the static code analysis with ArchUnit. We have different tools for that. For ArchUnit, we want to test an architecture. So let's assume that we have a layered architecture and we want to keep those rules automatically. So take a look at that. So we have a architecture test defined in our unit test. Defining architecture rule and layer dependencies are respected with an exception. Here we have a layered architecture DSL from ArchUnit, and we are actually describing the layered architecture. We might have a layer controllers defined by package controller. You might have package services and so on with package persistence. And here you're going to define rules on that. So you define that layer controllers defined here may not be accessed by any layer, right? Because the controller is a top level package here accessed by an API, not by Java code. And here later you can define that layer services can only be accessed by layer controllers, right? So layered architecture and layer services. Layer persistence can only be accessed by services. So this call is not allowed. ArchUnit will report a violation once you try to do this call, unless you ignore the dependency. Like service violating layer rules class can do it. Other classes cannot. So here is the layered architecture. You might get something more from ArchUnit, like slices. And slices is a more generic concept in ArchUnit. You can define slices as whatever you want. For me, slice will be a module. Right? So in my modular architecture, slice will be a module. So let's say that we have two modules here, GDPR and OAuth2, and we are defining a rule between those modules. Let's say that we have slices matching controller. We are naming them as controller. This $1 is a name, so controller, a GDPR controller. As controllers should not depend on each other, right? So controllers cannot call each other. So this rule means that this call is allowed because it's not forbidden, so this is allowed, right? More examples from ArchUnit you might get from ArchUnit examples repository. There are two contributors. However, those two contributors are actively contributing, and this repository is very useful. In documentation, you might also get a description, but also some diagrams, right? So here you can see that no classes that reside in package source should depend on classes that reside in package foo. So this is forbidden by the rule, which means that this is allowed by this rule. You might have other rule that will forbid it or limit it or restrict it, but this rule allows it. So now let's come back to the modularized monolith and how ArchUnit can help here. So the rules, I'm going to present the rules that firstly I defined as a as a sentence, and then how we crafted the architecture ArchUnit code for that. The first and the most important rule was that module can only be accessed via API. Right, so module has its API, and this is the only entry point to the module. You cannot call internal service or internal repository. You need to call a module API because this is the method that is tested, that has required validations. So you cannot call a user repository safe on repository. You need to call user API safe because save a user involves some validation, some business logic. It's a creating a new user, in fact, not just saving a row in a database. Yeah, so what does it mean? It means that this is what I actually said. I forgot to change the slide, to be honest. This is what we need to allow by this rule. So calling a module API and restricting calling a module internals. We've implemented this rule, and as an interesting point, I can tell you that we had almost 3,000 violations. I'm pretty sure that we got even more. However, once I checked out the old revision on repository, I couldn't replicate it, and I got 3,000. I'm pretty sure that we've had 5,000. Nevertheless, this is very much. Like you see, we implemented the rule, and we cannot enable it just like that because we have too many rules. We need to enable it gradually, step by step, right? And eliminate violations step by step. So the implementation. This is the rule implementation. That's it. Again, I'm using ArchUnit trick or pattern, however you call it, that I'm hiding complexity under the fields. So even though the rule has 4 lines here, I'll show you later what is hidden here. But on those 4 lines, I can explain you what's happening. Oh, and what is happening is that we are taking the top level package from my project, com circle k. We are taking all sub packages here, so all those blue, and we are naming them as modules. So module GDPR, module infrastructure, and auth. Then we decide which module should be included in scan. For example, since we have 3,000 violations, we don't want to enable in scan all modules at once. So we will enable them gradually, and for start, TC module will be excluded. And the actual rule implementation is that each slice should depend on other module via API only. But let's start. What does it mean to include a module in scan? It means that a module is listed in a hash set, in a set, right? As you see, TC is not listed here. We will enable it later, and the implementation here looks as follow. So we have a describe predicate. We have a predicate. This is an ArchUnit concept that slice, meaning module, should be included in scan. We have some boilerplate because of interface definition. It's not functional interface, so Lambda cannot be used here. But the important part is that here we are checking if module that is being scanned, that slice contains the module. So the set of scanned module includes the module that is going to be scanned. If not, then we continue scanning next modules. If yes, then we are scanning this module too. Let's skip to the actual rule check, which is the clue of this presentation, I would say even. So the most important part is to write an architecture condition on a slice that slice should depend on other modules via API only. Here we have a boilerplate, and here is the important part. We're taking the slice, the module, and taking dependencies from self, which means that we are checking who the class is calling. Here, who the class is calling. We're checking each class in a module and checking who the module is calling. And as you probably might think, there we are checking if the class is calling module APIs only from external modules. If it's not calling, we will be validating if it's not calling the module internals. Okay, then we are filtering the dependencies that do not belong to project. So we are excluding Java util list and so on, because ArchUnit allows you also to scan the framework and library dependencies. We're filtering, ignoring the not modularized packages. So we have infrastructure package, utils package, and so on. That is not a business module, so we exclude it from scan simply. And here we are checking the rule. So we are filtering dependencies referencing classes that are not API. So if something is not API class, we are going to prepare a violation report. So it's going to be added to the report. And the rule violation message looks like that. Let's say that we have class TC group, and it must not be referenced from method in some class. And we have a link to illegal dependency. So that shows that we have an illegal dependency to external module, which is omitting the module API. And actual dependency, what does it mean that the something is referencing class that is not API? We have a predicate, we have a dependency, which dependency has the class that is calling and the class that is being called. Class that is being called is a target class. And if target class is not annotated with module API, which means that this is the class that is module API in our case, or the class being called is not in application API package, that means that this is not a module API. And here we are failing this predicate and reporting an error. And that's it, the most important rule in our project. Another rule that we came up with is a module API. Module has API, so each business module must have API. It is implicitly checked by the previous rule because once you need to call the module via its API means that this API exists. But let's take a look at the implementation. I wanted to show you a different rule, how it's implemented in ArchUnit. So we have a definition here that rule that all these slices matching that are business modules, similar thing, should have API. And should have API means that we are checking if module has API class. So we are scanning every class in the module and checking if any of them is annotated to the module API, or has API package. This is a different way to define a module API. So if package name contains some application API. If it is, then fine. If there is no such module API, then we are reporting a violation that API should be there. Another rule, and here I'm going to warn you, so ArchUnit is not able to do everything. Every module API must have tests, must have unit tests to be precise. And in our case, unit tests are written in Spock and in Groovy because we are on Java. And Groovy is a dynamic language, and ArchUnit is not able to find references to the Groovy tests, Groovy implementations. This is why we were not able to write this rule. This is a drawback in ArchUnit. We were able to find a test calling a module API in JUnit test because we also had several such classes, but not able to find Groovy references. Another rule that we were thinking of introducing, but we stopped and we canceled and we aborted, was to enforce module internal architecture. And we decided not to do it because we decided that each module can be independent and each module can choose the internal architecture on its own. Like it can be layered, it can be onion or hexagonal or CRUD or whatever, depending on the business module requirements. And now the process of implementing the rules. So once we have our rules, how to implement code changes so that those rules are met. First of all, we prepared a new build step on Jenkins. So this is a new continuous integration step to verify architecture rules. And it was included in every build. So after each build, we are checking if the architecture rules are met. We decided to pick modules one by one and start with the simplest module, the smallest module, the simplest module, the freshest one, the one that was crafted recently, so that we know that it follows the newest conventions in our code, and it should be modularized. And what is the result? We were reported with around 50 or 60 violations. And it might sound scary, however, some of those violations are repeated, because once you break one rule on one class, like for example this on utility class, the UIT parser that was being a part of different module, and in fact it should be a util. It was called from several places from this module, which means that moving an UIT parser to utils, resolved several violations. Also, scanning this simple module allowed us to find where, in fact, we should elevate some classes that are module internals sometimes, but they are in fact a module API, like DTO on module API, like application type, for example. So the approach is like a kind of TDD approach. So first, you need to see red tests, right? So you enable the rule to see the tests failing, and you do the minimal effort to make tests pass. Minimal effort means that you are moving a classes across the packages or into modules, and doing that until your tests are green. And in regular TDD, you fix the design in the same pull request. However, here, fixing involved a kind of architectural changes. So we decided to write a separate task and do a separate pull request to fix the design. Okay, and the next module was in fact a bit bigger. And the interesting part is here that it turned out that user repository, which was module internal class, it was a repository data access layer, was used by other modules, and it was used heavily, right? So de facto, it was a user module API. We didn't want it to make it API and to be the API. However, currently it was like that, right? So we decided as a minimum step to make test screen, we decided to move the user repository to API and later fix it in the next pull request. And this is what we did. Okay. The next thing was we also, on our journey, we also identified several classes that were a code smell, and we simply removed them, like client ID parser. On the previous slide, I had a OID parser. Now we have client ID parser that has similar responsibilities. However, client ID parser was a code smell because it was throwing some business exceptions. And during those refinement sessions, we noticed that it's a code smell. So we removed that. And here I'd like to mention also a mob programming, which is something you might know is a pair programming. Mob programming is not that popular. In pair programming, you have two developers sitting together in pair and coding stuff. In mob programming, you have whole team sitting and coding one thing. So one person is coding, rest of the team is discussing. And this is a good case where you have a lot of discussions, right? When you're deciding where the class should be, where the module boundary should be, how utils should be organized. Because, moving classes across the packages is a, minimal effort in IntelliJ, but discussing where to move it requires a presence of the whole team. Also, the pull request after moving a class is big, right? But once the whole team was observing it, then pull request is not needed actually because they were reviewing as you were developing. And other simple modules comes next. And we've had also several classes that we identified as code smells. Basically, it started to get boring at some point because, well, following refactorings were similar, and there were difficulties in the beginning, but later the refactoring we were following, the path that we've decided before. So this is a good news because it means that it won't be difficult all the way down, but it will be difficult only in the beginning. But also, it won't be faster because there's a lot of code to refactor, and it takes time. Right? Yeah. So at some point, we also created a new module. A new module creation is time-consuming as well. As you see, we've had a pretty much discussions on pull request, and pretty much files were changed. However, those classes were scattered across other modules. We decided to create a module, and it was a good decision. And the largest modules comes last. We left them the oldest, the largest, the most complex modules as last because we resolved all the small problems in the beginning, and now we can tackle the biggest modules. You know, the small problems in the beginning look like small right now, but in the beginning they were not that small. A trap that I want to mention here, I'm mentioning here only, you know, a kind of generic things that might happen to you also, not a domain specific. A cohesion. Let's say that we have a user module that is managing users and a sign-up module that is enrolling new users. And both of those modules are using address as a class, as a user property. So this is a kind of shared class. So address is being shared on the sign-up and on user management as well, which is a pretty good approach. However, we have a lot of other modules in our system. So the cohesion is small here because, you know, this address class is not being used by other modules. It's being used just by user and sign-up modules, which might lead us to the conclusion that, you know, that maybe user and sign-up should be merged into one module to increase the cohesion, or any other solution like sign-up could be sub-module of user module. So you might approach it differently. And are we done? Does it mean that we are done? The next steps for us would be submodules. Should we define submodules within a module? And what rules should it employ? It's to be decided here. We don't have that complex modules that we should define submodules. And another thing that I think that we have already agreed in the team that we won't do is the rule on module internals. The internal module architecture can be whatever you like. We decided not to enforce the rules on module internals. In one module, you might have layered, in other onion, in other CRUD, in other, you might have even a mess. The important part is that you keep it in a module boundaries, enclosed, encapsulated. And that's it. That's everything from my side. Thank you so much. And let's go back to the studio now.
Yeah, thank you, Jacek. Yeah, and I invite you to join to our Q&A room to continue the live discussion with participants. So you can find the link in Rocket platform in the discussion menu. So thank you once again for supporting Devoxx Ukraine this year. Yeah, hopefully next year we can meet in person in offline event.
Thank you. Yes, I would really love to see people in real, not just my laptop in front of me.
Yeah, that's true. We all miss this. Okay, thank you, Jacek, and yeah, dear participants, I invite you to continue the discussion in the Q&A rooms.
Thank you. I'm heading to Rocket right now.